Hey stats kids, here I am to work your review. I will be making notes along the way and filling out all I can fill out. Okay, so for this two-way table to fill it in, I know I have 200 at the total, and I have 109 11th graders, so that makes 91 12th graders. Of those 91 12th graders, I know 75 like fire and ice. So that means that 16 like the roaring 20s. And then 57 plus 16 in the roaring 20s equals 73. And if you check it, it should all add up to 200. So the first question says, determine the number of 12th graders who prefer the roaring 20s theme, which we just calculated to be 16. So that is answer choice A. Looking at our table above, what's the probability that a student can choose fire and ice and the roaring 20s? Well, you can't choose both. So that is a none because you cannot choose both themes. They are disjoint, or if you want to say the themes themselves are disjoint or mutually exclusive. Okay, what's the probability that a student from the survey is an 11th grader or chooses the roaring 20s? Well, there are 109 11th graders. There are 73 that chose the roaring 20s. And then there are 56 that chose both that we have counted twice. And when I add that up, I get 125. And then there were 200 total students. So that calculates to be 0.625 for the probability. What's the probability to number C or letter C? What's the probability a student from the survey is a 12th grader and chooses fire and ice? There is only one grouping where that intersects, so that is 75 students out of 200 total, which is 0.375 for my probability. Oh, I don't like how that looks. Okay. So now we're off the two-way table and we are going to a word problem. It says a combination can be opened using one letter from A through Z and one number 1 through 9. With the letter being the first in all possible combinations, how many possible codes will there be known if the correct code includes a vowel? So we have a vowel first, and then the next one is divisible by 3. Well, there are 5 vowels in our alphabet, and 3, 6, and 9 are the only numbers in that list that are divisible by 3, not 9. Sorry, y'all, that should be by a 3. And 15 times 3 is 15 possible combinations or possible codes. Okay, Plano East, number 4. At Plano East Senior High, students were polled to see what kind of pets they had. The results showed 40% have a dog, and 25% have a cat, and 10% have both. What percent have neither? So you can either do this as a Venn diagram, which I'm all for, and that would put 1 in the middle. Ooh, that's a bad circle. I'm glad this program works to fix that. Let's make that a little bigger. And then okay. So with 10% having both, that means that for my cat, there's only 15% have just a cat, and only 30% have just a dog. If I want neither, they cannot fall. They cannot fall in any of these categories. It is, so you're going to do 1 minus 0.3 minus 0.10 minus 0.15. And you get 0.45 have neither. Okay. Number 5, in a given situation, the probability of A is 40%, the probability of B is 30, and the probability of A and B is 12%. Are the events independent or dependent? Okay, so definition states that if independent, then the probability of A times the probability of B is equal to their intersection of A intersection B. So if we check over here, probability of A is 0.4 times the probability of B is 0.3, and when I check, that does equal 12. So probability of A and probability of B are independent. Okay. What is the probability of the union if you have those information? Based off definition, probability of union says probability of A plus probability of B minus their intersection. So that is 0.23 plus 0.41 minus 0.12, which is the union, which is equal to 0.52. Number 7. So number 7 in our Venn diagram, we are not given not giving probabilities, we're actually giving values for each part. And so on this one, we have 200 students in Richmond High. S is for the students who play a sport, and A is for the art class. How many do not play a sport? That is, again, 1 minus 68 minus 41 minus 73 to get what's outside of all of that. Oh, wait. Nope. No, that's not. Ignore me for a second. That is what goes out here. To get the ones that don't participate in art or in sports. But how many do not play a sport? So that is probability of sport complement. So that is 1 minus 68 plus 41, which is 91 students. A student selected at random at Richmond High. What's the probability that the student plays a sport or takes an art class? Okay, remember, or is add. So when you're talking about or, it's got to be all of the S circle and all of the A circle. So that is going to be 68 plus 41 plus 73, all divided by 200, which works out to be 182 divided by 200, which is 0.91. Okay, what is the probability that the student plays a sport? That is just the sport circle. So 68 plus 41 over 200, which is 109 divided by 200, which is 0.545. Okay. New restaurant is open in town. There's a 20% chance customers will order an appetizer and a 60% chance that they will order dessert. Assuming ordering an appetizer and dessert are independent, so that's key, what's the probability a customer orders an appetizer but does not order a dessert? So what you're looking for is the probability of appetizer intersect dessert complement. So an appetizer is 20%, intersection means times, and dessert is 60%, so the complement is 1 minus 60% or 40%. And when you multiply that, that is 0.08. How many unique ways are there to arrange the letter in girls? Okay, with that, order matters. So that is 5 permutations of 5, which is 120 ways. Okay, 2% of Americans are redhead. What's the probability that in a group of 8 Americans, at least one is redheaded? Now remember, first of all, let's calculate probability of no red hair is 0.98. And remember, at least equals 1 minus the probability of no red hair. Now, I only did no red hair for one person. This is for 8 people. So, first of all, that knocks A and B out. So it only leaves C or D, and in this case, the answer choice is D. In this, on number 11, it says, consider the diagram below. And the diagram below is showing everything but B is shaded, so we're looking at B complement. So what does the shaded part of the Venn diagram represent? Well, I just answered that, B complement, which is answer choice C. 12. Suppose upperclassmen, a junior or senior, selected at random. J represents the student as a junior. D represents they're going to the dance. What's the probability notation that would represent the probability that a senior and is going to the dance? Well, probability of a senior is a junior complement, because it's the only other option. Intersect, because we want and going to the dance. So that is answer choice B. John bought a machine to make fresh juice. Sorry, I can't read all of a sudden. He has 5 different fruits. He has strawberries, oranges, apples, pineapples, and lemons. So 5 fruits. If he only uses 2 fruits, how many juices can he make? Well, we're only looking at order does not matter. So it's a combination of, and you always have the larger number on the left. Okay. If a probability that package produced from a certain company has pesticide residue is 0.3, what's the probability that that 3 randomly chosen packages all have the residue? So that's residue intersect residue intersect residue is the probability we're looking for. Remember, intersection is multiply, so it's 0.3 times 0.3 times 0.3, which is 0.027. Answer choice D. The probability that an article is accepted for printing a certain journal, is 25%. Jake submits 3 articles. What's the probability that the first article will be accepted, but the second and third will not? Okay, so I wrote down probability of accepted is 0.25. Probability of not accepted, which is accepted complement, is 0.75. So his first one's accepted, his second one is not, and his third one is not. And when I multiply all those together, I get 141. And not every answer on this worksheet is in 3 decimal places, but remember, that's what I'm looking for is 3 decimal places. Suppose a coin is weighted so that the probability of heads is 0.6. what is the probability of tossing a head on the next 3 tosses? So we want probability of heads intersect heads. Oh, it's 0.6 times 0.6 times 0.6, which is 0.216. Okay, a coin purse containing 5 dimes, 3 nickels, and 4 pennies. So we have a total of 12 coins. But we want, if the coins are not replaced, we want a nickel, a dime, and a penny if they're not replaced. So for a nickel, there's 3 out of 12 nickels possible on my first pull. Then a dime, so there's 5 because we have not pulled a dime yet, but there's only 11 coins left over. And then we want a penny, and we haven't pulled a penny yet, but now there's only 10 coins left over. When I put that in the calculator, I get 1 over 22. I used the stack fraction on 17 so that I kept the fraction because my answer choices were in fraction. If they weren't, I would have just put the decimal. Even if you didn't, you can compare the decimal version to the fractions that are there. Okay, same thing on 18. 3 coins. We want this probability, nickel, and penny, but this time they're replaced, selected randomly and replaced. So that changes my denominator. Still have 3 out of 12 because it's the same problem as above. But now for my dime, I have 5 out of 12. And for my penny, I have 4 out of 12. And when I work that, it all becomes, again, I did this in a stacked fraction. So it becomes 5 out of 144, which is A. Okay. The probability of selecting a sample blood type. So we have, this is problem 19. O, A, B, or AB are 0.45, 0.4, 0.10, and 0.05 respectively. So remember, respectively means in order. So type O is 4, 5. Type A is 4, 0. Type O is 0.10. Nope, that's not O. That's B. Sorry, we had already had O. That is B. And type AB is 0.05. What is the probability that is either A or O? And these are mutually exclusive. You can't overlap blood types. So 0.45 plus 0.40, which is 0.85, which is answer choice B. Company-held handheld vacuums has a 3% effective rate. What is the probability that a sample of 3 randomly selected units has no defects? Okay, probability of no defects equals 1 minus 0.03, which is 0.97. And we want 3 of those. So 0.97 times 0.97 times 0.97. Which multiplies out to 0.912673. Okay, 8 Olympic swimmers. You want gold, silver, and bronze. Maybe. Gold, silver, and bronze. And in order to do that, that means that order matters. So that is 8 permutations of 3, which is 336. Okay. Chess club member may elect a president. Once the president is chosen, then any other member may be elected secretary. And after that, then after president and secretary, then we get treasurer. In the drama club, any member can be selected to its 4-person steering committee. In the chess club, order matters, where in drama club it does not. So the only one that it applies to is B. Combinations, because order doesn't matter in combinations. Permutation order matters. How many ways can we get first, second, and third place winners with 4 people? Again, order matters. So you're looking at 4 permutations of 3.